Hey guys, in this video we're going to go through the 2.b.i solving quadratic equations mixed assignment. So it's kind of a combination assignment with different factoring pieces and practice. Alright, so let's start with this first part. Solve for all values of x by factoring. So we are going to go ahead and make sure first it's set equal to 0. Check, yes. Is there a GCF I can pull out? Nope. So now I'm going to figure out what multiplies to my AC value and then adds to 10. So figuring out what multiplies to 21 and adds to 10. So we'd end up with 3 and 7. Yep, that'll do it. X plus 3, x plus 7. And so then now I can separately set those equal to 0. Whoa, got some craziness going on. And solve. So x equals -3 and x equals -7. Cool. All right, let's do one more of these ones. All right, so in this problem, I have x squared minus 3x equals 4x. So the first thing I'm going to do is get it set all equal to 0. X squared minus 3x equals 4x. So I'll subtract 4x over to get it equal to 0. So I have x squared minus 7x equals 0. Okay, so now it's set equals 0. Check. Is there a GCF I can pull out? Absolutely. In this first term, I have 2 x's. In the second term, I have 1x. So the most I can pull out is 1x from each of those terms. When I take away 1x from x squared, there's 1 left. Then I still have minus 7, and then I took away the 1x on the second term. So that's good. Separately, I set my factors equal to 0. Remember, it's okay that this is a factor. That's fine. So x equals 0, and then I set my other factor equals 0 as well. So x equals 7 is one option, and x equals 0. Cool. All right, let's do one more from this section, and then we'll move on to some more stuff. So I got x squared minus 5x equals -2x. So x squared minus 5x equals -2x. Is it set equal to 0? No, so I'm going to go ahead and do that. Okay, is there, now that it's set equal to 0, is there a GCF I can pull out? Absolutely. Both of these terms have at least 1 x in them, so I can pull out 1 x. I'll have 1 left over in this first term, my minus 3 is still there, and I took out that 1 x that term had. So then I separately set my factors equal to 0 and solve them. So x equals 3, x equals 0. Awesome. All right, let's go ahead and try in the next section. So in this section, I have, a lot of stuff that's definitely not equal to 0. So I'm going to go ahead and get that all set up nicely for myself. All right, so I'm going to minus my 2x over. So I'll get x squared plus 12x equals -32. Then I can add 32 over. X squared plus 12x plus 32 equals 0. Then I have to figure out, because I have, there's no GCF, right? So I figure out what multiplies to my AC, my 32, and adds to 12. Let's see, that would be 8 and 4. Yep. So I get x plus 8, x plus 4. Separately set those factors equal to 0. And solve. So x equals -8, x equals -4. All right, let's do one more of these. I've had quite a bit of practice with these ones. So x squared minus 5x minus 28 equals 8. First thing we gotta do is make sure we get it set equal to 0. So I'll subtract 8 from both sides. So I got x squared minus 5x minus 36 equals 0. No GCF, so I'm going to figure out what multiplies to negative 36 and adds to negative 5. So I think 4 and 9, some combination of that will do it, but I need them to add to negative 5, so I need my 9 to be negative. Yep. X plus 4, x minus 9, and then I separately set my factors equal to 0 and solve. X equals negative 4, x equals 9. Awesome. All right, so let's go on to some solve by trinomial factoring when a is greater than 1. All right, first things first, I got to get it set equal to 0. So x squared, 2x squared plus 17x equals 4x minus 6. So I'll subtract 4x from both sides. So I'll get 2x squared plus 13x equals negative 6. And then I can add 6 to both sides. 2x squared plus 13x plus 6 equals 0. Okay, so now I have, there's no GCF I can pull out. And this is a quadratic where your leading coefficient is greater than 1, right? There isn't just a 1x squared here. I actually have an a value that I have to deal with. So this is where we use our reverse box method, okay? And so to do that, we first figure out what multiplies to AC and adds to your b value. So here my AC would be 12 because I do 2 times 6. And my b value would be 13. So what multiplies to 12 and adds to 13? Well, that would be 1 and 12. It's a pretty easy one. All right, and so then now that you have that, we're going to go ahead and we're going to stick all of the important pieces in our box that I want to make sure to draw in a good spot. And again, I'll try to kind of identify which pieces go where. So my 2x squared goes in the top left-hand corner. And my constant plus 6 goes down here, positive 6. And then I take my factors that I just found and I stick them with x's in my other two boxes. No, it doesn't matter which one goes where. Now what we're going to be doing is we're going to be pulling out GCFs from, I think I want to do this, each row and each column. So what is the GCF between 12x and 6? That would just be 6. What is the GCF between 2x squared and 1x? Well, that would just be 1x. Then we can do the GCF of each row. So what's the GCF of 2x squared and 12? Well, that would be 2x. And what would be the GCF of 1x and 6? Just the number 1, right? Because I can't pull out x's or 6's. Okay, and so then these are your factors right here. Okay. So now I have the factor 2x plus 1 and x plus 6 equal to 0. I can separately go ahead and set my factors equal to 0. And then I can solve. So x equals negative 1/2 is one answer. And then x equals negative 6 is my other answer. Negative 1/2, negative 6. Awesome. They won't show you the box method going from here to here, which is why I wanted to write it out very specifically. But there you go. Let's try to do 2 more of these ones because they're just a little bit longer. They're a more complicated version, but as long as you just follow these steps every single time, you're going to be all right. All right, so we start off with 5x squared minus 22x plus 11 equals 3. First thing we have to do is get it set equal to 0, so I'll subtract 3 from both sides. 5x squared minus 22x plus 8 equals 0. There isn't a GCF that I can pull out here, and I have a leading coefficient that is greater than 1, so I'm going to use my reverse box method to try to solve this bad boy. So we figure out what multiplies to a times c. 5 times a is 40, so that's ac, and then what adds to negative 22. Oh goodness, let's think about this one. So 1 and 40, 2 and 20, oh there you go, 2 and 20. But I need it to add to negative 22 and multiply to a positive 40, so I think they need to both be negative. Yep. All right, so then I'm going to do my box. My 5x, oh, I didn't even finish my box, you guys. So embarrassing. There you go. All right, so my 5x squared goes up here. Then my constant plus 8 goes down here. My factors with x's go in here. And then now I'm going to find some GCFs. So GCF of this column is negative 20 and 8. I believe 4 goes into both of those. And remember, because I'm pulling out the GCF and my closest box to the outside determines whether it's positive or negative. So I'm actually going to pull out a negative 4 because this negative 28 is at the top of this column. All right, from this column, I'm going to pull out just an x, I believe. And then from this row, I can pull out a 5x. And then from this row, I can pull out a negative 2. And again, because the closest box that I'm pulling stuff out of has a negative, I have to have a negative that comes out as a GCF as part of my GCF. So there's one factor, there's another factor, and then now we can rewrite our quadratic equation. I have 5x minus 2 and x minus 4 all equal to 0. I separately set those equal to 0 to solve for or to find my solutions. So x equals 2/5 is one answer, and x equals 4 is my other one. Cool. If you still need more help factoring, I've run out of time in this video, but if you still need more help factoring with the box method, make sure to check out the optional extra video examples, okay? Let me know if you have any questions.